question was this question. Okay, I'm going to put it, because it's a 2-sentence question, I'll put it on the chat. Okay, this was the question that you got wrong.
For this question, what is the
Okay.
rate of reaction in the 4th minute of the experiment?
Mohammed's quiet because he's thinking, I don't know what the 4th minute is. Do you, Mohammed?
Yes, it's here, this one.
Or do you know what the 4th minute is? You tell me.
It's on the table, sorry. The table.
Yeah, but what does the question say?
Analyze the graph.
Yeah, and here's a little insider tip. Okay, a little insider tip. What did the exam board say we needed to do?
Interpret the chart graph.
And graphs. Here's the thing, right? So we've interpreted the chart already. You're happy with that. Now we're interpreting the graph. Okay.
Yes.
So it's good stuff, right, Mohammed?
Yes.
Good stuff, Hamza. Yeah.
Yes, sir.
Good. Right. Okay. So back to the question. Analyze the graph of time versus volume of hydrogen for this question. What is the rate of reaction in the 4th minute of the experiment? Mohammed, where is the 4th minute? Prove to me that you know where it is.
It is in the top.
Where is it? So if I go to the drawing, okay, tell me where the 4th minute is. Can you see the drawing?
Yes.
Okay, can you see my cross?
Yes.
Okay, tell me to move up, down, left, right, and to mark it. Okay, so if you want me to draw, just say mark. Okay, keep going. Up. Right?
Down.
Yeah, keep going.
Go right. Yes, here.
Okay, so you want me to mark there?
Yes.
Is that where you think the 4th minute is?
Yes.
Okay. Yes? 100%? 100%?
Yes.
All right. Okay, I'm going to remind you of what equation we're using to work out the rate. Okay, can you read that?
Yes, sir.
Okay, read. Go on.
H2.
H2, hydrogen, yeah. Divided by?
Divide by change time minute.
Okay, good. Right. The key here is this word here, change. Mohammed, what you've got is you've got one reading. There's no change that's happening. At that point in time, if I go for 2D shapes, here we go. That's reading across there. Okay. All right. So that's reading across at 38. Okay. So you don't have a change. You don't have a change there. Okay. There's no change there because you've only got one reading and you need to have a change. Okay. You need to have a change. So go back to the question itself. What's the question asking you? You're analyzing the graph. You're doing that. So the question is asking, what is the rate of reaction in the 4th minute of the experiment? So you need a change. You can't just... do you see what you're doing wrong on this one?
Yes.
Yeah. Yeah, you're just giving a reading. You're just saying what the volume is. Time equals 4 minutes. That's where you're going wrong. Okay?
4 to 5.
Okay, now if I go back to your answers, I'll tell you what answer you gave in this. Actually, you gave 2 different answers. Mohammed, you gave 11, and Hamza, you gave 8. And both of you were wrong. Okay, all right. Yeah, it was interesting because I'm not sure whether you knew where you got the 11 and the 8 from.
No, so that time I was confused. Now I understand.
Yeah. Okay, that's fine. That's fine. I'm happy with that. If you just chose it randomly, that's fine. Mohammed, were you just confused as well?
Yes.
Okay, all right. So the random question, random answers. That's not a problem at all. Okay, but now we're working out a change in volume and a change in time. Okay, so what clues have we got from the question about volume or time? Have we got any clues about any of those terms? Volume, change in time? What's the clues? Look at the question. The clues in the question.
Fourth minute, sir.
Fourth minute.
Yes.
Okay, so Mohammed, what do you think?
It's the changes from the 4th minute to the beginning of the 5th minute.
Okay, right. Okay, we're making progress here. All right. Okay, right. Let's verify that answer. Okay. Can you see that?
Yes, sir.
All right. Okay. So you're going to count with me, Hamza.
One.
Which minute is that?
1 minute.
No, first.
Yes. First.
First. Okay.
Second.
Okay.
Third.
Okay.
Fourth.
Yeah, I've run out of space. Hold on. Mohammed, what's gone wrong? What did you do wrong?
We went to the 5th minute.
You went for the 5th minute. Okay. So that's where you're going wrong. Okay. That's where you're going wrong. I haven't changed the picture. I have not changed the picture. You're looking at that picture and you're thinking, hang on a second, I could have sworn that that was the 4th minute. Correct?
Yes.
Yeah. But when you're looking at time, you have to remember how many minutes have passed. Okay? All right. How many minutes have passed? That's I know it sounds basic, but it's a real trick that you need to make sure you don't fall for. Okay? All right? Okay, so are we looking at this one over here? We're not, are we? We're not looking at T4. We're not looking at this space over here.
No, sir.
Our zone is in this zone here. Okay? That's our zone. That's where our attention is. Okay? You with me?
Yes, sir.
Yeah? Okay, go back to the question. Mohammed, it says, what is the rate of reaction, right? We've got an equation now that is telling us what to work out for this rate of reaction. So here, we have to do a calculation. We can't just say it's low, it's high, it's gentle, it's going up, all right? We do have to do a calculation. So how do we work out the rate of reaction in this 4th minute?
Divide by 20, right?
Okay, Mohammed, what do you think?
I think we calculated by dividing.
Dividing what by what? Don't have to give me the numbers just yet. Just tell me what I would write in the equation. The change in volume.
I can one divide the change in time.
Hey, wow. Do you mean the change in volume by the change in time?
Yes.
Okay, say that then.
Divide change in volume by the change in time.
Correct. Okay. All right. I think that's what you meant, but the translation got muddled. Right. Okay. So you know what my next question is now, don't you? What's my next question?
What is the rate of reaction before?
Yeah, so we're working out the rate of reaction. The rate of reaction can be rewritten as change in volume of hydrogen divided by change in time. So what's my next question? Or I've got two more questions. What have I done the arrows? What's the question I'm about to ask? Mohammed, what do you think?
what is the change of volume?
What is the change in volume? Thank you. Right? So what's the change in volume? What's my next question after that?
What's the change in time?
Correct. Okay. Which one of those is easiest?
What and change in time?
Time.
Okay, all right. So Mohammed, you tell me what the change in time is for that time period.
It's 1 minute.
I like that. Okay. Hamza, you tell me what the change in volume is.
1 minute. 1 minute.
1 minute. Change in time is 1 minute. No, we got that from Mohammed. Hamza, you're working out the top bit now. Okay. Change in volume. So what is the change in volume in that time period?
38 centimeters cubed.
38. Where'd you get that from? This one here. Change in volume in the 4th minute. Can't be. That's the change in volume after 4 minutes.
Okay. Before
Yeah. No, wait. It's important for us to be clear on this. What you've just told me is the change in volume. Change in volume after 4 minutes. Okay. Yeah.
So it's
But what the question is asking you is what's the change in volume
in 3 minutes.
in the 4th minute? Do you get me? The question, okay, all right, I'll help you. The question, the original question, look at the chat. The question is saying, what is the rate of reaction in the 4th minute of the experiment? We know that the change in time is 1 minute because that's how far apart the start and the end of this 4th minute is. So that is correct. Okay, now what we need to do is we need to figure out not just the change in volume of hydrogen, but the change in volume of hydrogen in that minute.
Okay.
Okay, otherwise, I know you're right. Otherwise, what you're doing is you're working out the rate of reaction over 4 minutes. And that's not what's being asked. If the question was asking that, it would be asking what's the average rate of reaction over the first 4 minutes of the experiment. But what the question is actually asking is what is the rate of reaction in the 4th minute? Now you notice that earlier I was very, very insistent on you using the word in and by very carefully. And this is the reason why. Okay, so where you can make more progress is actually read, you get teachers saying, read the question again, it doesn't help, right?
Yes, sir.
But look at the actual words that are connecting the ideas and the concepts and the different things within the question itself, because it's giving you how to relate rate of reaction and 4th minute. The key word here is in. So it could be, they could easily turn around to you and they could say, what's the rate of reaction between time equals 3 minutes and time equals 4 minutes? That would probably be a clearer, easier way, right? But what they are expecting you to be able to handle is if they just say, in the 4th minute. Okay, in the 4th minute, all right? So it's the language, right? Now that I've given you that information, let's work out what the rate of reaction is in the 4th minute. So in the 4th minute, what you'd have to do is you'd have to work out the change in volume. We've got the change in time, the change in volume. What is the change in volume in that 4th minute?
33.
You can't go to 33. You can't go to 33. You have to start from the start of that time interval.
Okay.
You have to. Okay? Right? So you could say 33, but you have to do something with that 33. I may have jumped in there Were you wanting to say something else about that 33? Were you wanting to say something, or did you just think it was 33?
No, 33 centimeters cubed, and then you have to divide it by 0.5.
Right. Okay. Right. I get where you're coming from. Right now, the good news is that you don't have to worry about 0.5 minutes because it's in the fourth minute. So in the fourth minute is how long in minutes, Mohammed? How many minutes long is the fourth minute?
1 minute.
1 minute.
1 minute, okay? So we stick by 1 minute, all right? But what is the change in volume in that 1 minute? It starts at 33, it ends at
38.
38. So it starts at 33, what does it end at?
38.
38.
38. Thank you. Right, now we're cooking. 38 minus 33. That's the difference. Okay?
5.
What's the difference?
5.
I say that again, there was a bit of lag.
5.
5.
5.
Yes.
So now you're telling me that it's 5 divided by 1, correct?
Yes.
Yes.
Yeah, so our rate of reaction in that fourth minute is 5 centimeters cubed per minute, correct?
Yes, sir.
Yes.
That was the right answer.
Yes.
Can you remember 5 being one of the options?
Yes, sir.
Okay, right. Okay, right. So 5 was the answer. Right, okay, so let's just have a look now. The next question that you got wrong, both of you got this wrong. But now I think you can understand this question because I think you've already given this answer to me. Okay. Here's the next question. Can you see that? Analyze the graph of time versus volume of hydrogen for this question. Okay. It's in the chat.
Oh, okay.
It's in the chat.
Oh, yes, sir. I know.
Yeah, but now you're going to have to give me the sentence. Okay. All right. Go on then.
Sir, it starts off at the highest point and then...
Okay, right. Stop. What did we say about the word it?
The volume of hydrogen starts at the highest point and...
Right. Stop.
No,
What's the question? What's the question asking?
What is happening to the rate of reaction as I click?
Right. Okay. So save yourself time. The only thing that you need to talk about is the rate of reaction. The way to structure your answer is to use the second half of the question. As the experiment progresses, the rate of reaction...
The rate of reaction between magnesium and direct hydrogen...
No, forget all that. That's just patter. You're wasting time. Yeah? You can answer the question faster. Okay? So, as the experiment progresses... 2 seconds, Hamza. Remember team effort, so what do you need to say at this moment?
What do you think?
What are your ideas?
It's correct.
Go on, say it again. So the way to have this sentence, right? The way to have this sentence, whenever you get a question like this, use the question to structure your answer, okay? So the question's asking you about the rate of reaction. So you must refer to the rate of reaction, right? So when you have your sentence, you can start off with, as the experiment is
moving.
Is what?
Moving.
No, just use their word. You don't have to rephrase it. Progressing, comma. Now refer to what they're asking. What are they asking you to talk about?
First thing, start off.
No. What are they asking you to? Because what I'm doing is I'm trying to guide you the rate of reaction. Thank you. Right. All right. The rate of reaction, because we mustn't excuse passion for expression. Okay. I can see you're passionate about the answer, but we need to be able to express the answer. Okay. All right. As the experiment is progressing, the rate of reaction. Now we need to punch the answer.
It starts at its highest point and then decreases.
No. We can't say starts at its highest point. Okay, because that doesn't complete the sentence. Okay, we're talking about the rate of reaction. Okay, all right. So when you say the rate of reaction, it starts at its highest point. You can simplify that. Just say what happens to the rate of reaction as time progresses. Sorry? Increases. Team effort. What do you think, Mohammed?
Also, it decreases because how.
You need to get Mohammed's ideas.
What do you think, Mohammed?
The rate of reaction decreases.
Hamza, what's your final answer?
It also decreases.
Decrease. Thank you. Right. So, Hamza, what we need to do is we need to understand that the word what is not the same as why. Okay? All right? Is that something that other teachers have told you about?
Yes.
Okay? All right? Okay. So, the word what is not the same as why. Okay? This is a describe question. It's not a compare. It's not an explain question. Okay. All right. So, all right. Okay. Good. By the way, Mohammed, you said that it starts off at its maximum value and does not change. All right. Until after 5 minutes, where it jumps down to 0.
Yes.
Okay. So what you said was that it starts off maximum, but it continues to be at its maximum until suddenly it levels off at 0. If that was the case, then this graph would be shaped as I've drawn in orange here. Okay? All right? You with me, Mohammed?
Yes.
Okay, all right. So I put that in there because I wanted to see whether people would make that mistake. Okay? Because there's a difference between it decreasing sharply and instantaneously. Okay, so the graph could be like a straight line here, and then there, suddenly, boom, it goes flat. But that's not what's actually happening in this picture. In this picture, it's gently, steadily decreasing as time passes. What you said, Hamza, in your answer was it increases and then levels off. And the reason why was because you were stuck on what is meant by a rate of reaction. So you just went for the default answer, which was let's talk about the height of the graph. Yeah? Okay? All right. Good. You guys look exhausted now. There are only 2 more questions that you got wrong.
No, the graph questions, I thought it was like the hard part.
Yeah, but you find graph questions hard in maths as well, don't you? Yeah? So graph questions are hard, but what do they... You okay? Okay, but graph questions require what?
Math.
Yeah, they require patience.
Yes.
You patience and perseverance, yeah? SEF qualities, right? There you go. Determination. All right. Mohammed, you okay?
Yes.
Right. Mohammed, do you want to take the first question or the second question? You both got the same question wrong. Same questions wrong. Do you want to take the first one or the second one? And then we'll finish. Analyze the graph of time versus volume of hydrogen for this question. That's what we're doing, right? What is there happening to the Oh, wait, I'm reading, right. What is the mean average rate of reaction over the first 3 minutes? Wait, it's Mohammed's question.
Oh.
How do we do this question?
So we find the mean of the first 3 minutes.
Yeah, okay, so go on then.
It's so the third minute of it's
Right, your struggle is trying to figure out whether you should actually go for the whole 3 minutes or the
not
third.
it's from the second minute to the third minute.
Right, okay, read the question again. Your approach is correct. Okay, your approach is correct, but you're missing the runway. All right. Do you get me? If you're a plane, your approach is correct, but you're missing the runway.
For the first 3 minutes.
First 3 minutes. So give me time intervals. What's the start of that time interval? What's the end of that time interval?
The start from 0 to the third minute.
Thank you very much. Right. So we are talking about the time interval 0 to 3 minutes. Okay. The mean average rate of reaction. Now we've been through the equation so many times, you should be able to tell me now what that equation is.
Time taken. The volume divide the time.
Okay. Is it volume or is it something else before that volume? Because you're saying volume and time taken, but it's happening over time. It's a rate. So we can't just pick a volume. We can't just pick a coordinate, all right? Because it's happening over the course of time, we can't just pick one volume. We have to pick more than one volume. Do we not?
Yes.
Yeah. So let's go back to the time. You corrected yourself. You said time equals 3 minutes. Then you corrected yourself. You said no in the third minute, and then you corrected yourself again. And all of this was good. You said between 0 and 3 minutes. So you can appreciate that you have a change in time taken, and that time is 3. Do you agree?
Yes.
Okay, but now what I need is the equivalent for volume. Okay, what I need is the equivalent for volume. All right, so you need to tell me what to do in order to get the equivalent for volume. Okay.
I don't know.
You do know, you can do it. Okay, so the experiment has taken place over 3 minutes, okay? From 0 to 3, okay? So your change in time taken is actually 3 minus 0. When you're working out the change in time taken, you get the final point and you take away the initial one. That's what Hamza did in the previous calculation. Because he said, oh, you find the difference, okay? And the difference, there's another word for difference, it's change. And that's what I've been using throughout. Would you agree, Hamza?
Yes, sir.
Yeah, okay. So it's not just volume, but it is the
change.
Thank you. So in order to work out a change, see, now your approach is correct, right? This is Mohammed Maghzoub Airways coming into Dubai Airport, and you've got the correct approach now, and you're going to hit one of the runways, right? You're going to land correctly, but you just got to now be able to make sure that you're landing at the right terminal, okay? Not departures, but arrivals, all right? So now what you need to do is you need to tell me what the change in volume is in that 3 minutes.
It's from the 0 to 33 centimeters
Thank
squared.
you. Thank you. And the calculation that you just did was 33 take away 0. And it's quite convenient that we start off at time 0. Okay, it's convenient. But if we had to find out time intervals, we would instead of 0, we would put the previous volume or the previous time. Yeah. So what's 33 divided by 3?
3 divided 3.
33
11.
divided by 11. That's it. And what's our units? So what's the units? What's the units?
Squared.
Squared? That's new. You're reinventing maths.
Cubed.
Cubed, okay. And it's per? What's the time taken?
Time taken 3.
Yeah. Units.
Minutes.
Thank you very much. Okay, right. So that works out. So when you have a question that's saying what's the mean one, you don't have to sort of figure out, oh, what was it there? I need to take it away from there. What was it there? I need to take it away from there. You don't have to do that. Once you know what your time period is, all you need to do is just work out what your endpoint one is, what it is at the end, and what it is at the start, and then work out your change in volume divided by your change in time. Okay, that's why you need to look out for the phrase mean average rate of reaction. It's a different question. Yeah, it's a different type of question. All right, you take a rest because you're in a currently hyperglycemic state. I realize it's gone on, but I appreciate it. Right, this is Hamza's moment. Okay, so Hamza, here we go. In the chat, this is your final question. Okay, this is the final question. Analyze the graph of time versus volume of hydrogen for this question. What is the rate of gas production in the 7th minute? Instantaneously now, you should be thinking, what's the time? What do I need to look at? Okay, the time. 7th minute. Take me through this.
I need to look at the time, and I want to look at the volume of
Okay, so let's talk about the time. Where I've got my crossover here. Where is the 7th minute?
Down the side, right.
Tell me again. Sorry, there's noise coming through. Say it again.
Right down at the
right and down. Okay, so I'm here. What do you want me to do?
Last.
So you want me to? So here.
Yes, sir.
Okay, so I'll read you the question again. What is the rate of gas production in the 7th minute?
7. So let me read the question again.
Yeah, that's fine.
So 0.
Yes.
The answer is correct, but I'm not sure that you actually got the answer in the right way.
So no, because there's no point for the reaction stops at 6.
Yeah.
So there's no
Go on.
nothing there's no point. There's no measured there's no how can I say? There's no point. So
Yeah, but you can see that nothing is changing, correct? There's no change in height. So you don't need another point. If you really wanted another point, then I could put another point here. There you go. All right, but you didn't need that because you actually had the evidence here. You already had the evidence because it was at 40, 40, 40, and 40. Yeah.
Yes.
Yeah. So so don't let that kind of thing put you off. All right. Okay. But I still need to come. Yeah, you got the right answer, but I'm still yet to be convinced that you know what the 7th minute is, because I kind of think that you just looked at 7.
No, sir. I saw the gradient. It kept.
Yeah, no. I appreciate that. I can see. Okay, right. So you talk about gradient. So here's my simple question: when does the 7th minute start?
Finished. Didn't quite.
Sorry.
After there's no 7th minute.
You see, There is a 7th minute.
It's from 6 to 7.
Mashallah.
Ah.
That's the 7th minute. Remember what I said right at the very beginning? That's the 1st minute,
Second.
2nd, 3rd, 4th, 5th, 6th.
Yes. Number 7.
That's the 7th minute.
Yes, sir.
Yeah. So comes back to my instinct. My instinct here was that you got the right answer, but you didn't get you didn't have the pathway to the right answer, because this question could easily have been, what is the rate of gas production in the 3rd minute? And I would have thought, with your previous approach, you would have said 33 take away 30. No, you would have actually said 33.
Yes, sir. But and then.
Yeah. Now, then you have to work out the difference, but then you would have gone 33 take away 0 equals 33, which would have been the mean.
You don't have to work after anything.
Yeah, so it's very important that you know where your intervals are. Do you remember right at the very beginning of the video? And when you watch this back, it's going to be a great video. Okay. When you watch this back, you'll see that I always was referring to intervals. My very first sentence was, work out what the interval is, where your starting point is and where your ending point is, because that is really what rate of reaction is all about. It's all about changes that take place over time. And we can't see the actual reaction taking place, but what we can make as chemists is we can make observations to determine what is actually happening. Okay. Now within that actual minute, you might have, or 30 seconds, you might even have, points where it's faster in the first 10 seconds than the third 10 seconds. You may, and you may even have some seconds that are faster than others, okay? Because you've got lots and lots of different particles reacting together, and you also need to take into account, this refers back to our previous lessons work, that not all of those collisions are successful. Some of them are successful, some are not successful. The successful ones are the ones that form your products, and the unsuccessful ones stay as reactants, and as time goes by, then they become products. That's why when you add these two chemicals together, you don't suddenly have an instantaneous reaction where every single particle reacts to form a product. Yeah, otherwise it would be shub. Your volume would automatically be all the way up to 40 right at the end. Okay, all right, cool. I think it's time for breakfast now, correct? What are you going to have for breakfast, Mohammed? Waffles?
I don't know. I'm gonna go.
Maybe some post-Eid baklava. I don't know. What did you have for Eid? Have you got any leftovers from Eid left?
Yes, sir.
I don't know.
You haven't got all the Eid food is gone. Is that right, Mohammed?
Yes, I didn't eat out.
Okay. What about yourself, Hamza? What have you got left?
Bro, we have so many. Mahmoud.
Ah, well. If you're in the Al Ruwaika region of Al Ain and you've got lots of baklava left, I know, plenty of teachers that will have your donations. I can tell you that. We all live together. Right. Okay. Thank you so much for joining. This is going to go on YouTube, and I think it's going to be a fantastic resource. I'm going to go off now and edit it, and I will have it as a special video for how to tackle graph questions, misconceptions in graphs, and you're going to star in those. How's that?
Okay. Thank you, sir.
Take care.
Bye.
Bye-bye.